On July 21st, 2024, a rover the size of a small sieve drilled a hole the width of a pencil into a reddish Martian rock and pulled out a cylinder of ancient mud. On September 10th, 2025, after 14 months of laser spectroscopy, X-ray mapping, and more than 1,000 scientists checking each other's arithmetic, NASA published a paper in the journal Nature calling what was inside that mud a potential biosignature. In 1996, a different Martian rock, one that had been sitting forgotten in an Antarctic ice field since a snowmobile search team nearly rode past it in 1984, got the same kind of headline, the same kind of press conference, even a comment from a sitting president. That case fell apart. This one, so far, hasn't. And after two Mars rocks, 30 years apart, backed by two of the most careful scientific institutions on the planet, the actual question everyone wants answered, was there ever life on Mars, is still officially unresolved. Here's what I think most people who followed this story now believe. And I want to say up front that it's a completely reasonable thing to believe, and also that it's wrong in a very specific, fixable way. I think most people believe that potential biosignature is bureaucratic code for "we're almost sure," and that the only thing standing between that Martian mud and the headline, "Life Found on Mars," is paperwork, caution, or some agency's fear of getting it wrong in public. I think people believe the case is basically closed and NASA is just being slow about admitting it. That belief isn't stupid. It's just aimed at the wrong villain. The actual obstacle has nothing to do with bureaucracy and everything to do with a problem geologists were already arguing about a full century before anyone put a rover on Mars. The problem has a name. Geologists call it equifinality, the fact that a single pattern, a single shape, a single chemical signature can be produced by more than one process, and once it exists, the rock itself keeps no record of which process actually built it. A river delta and a collapsed sand dune can leave nearly the same cross-section. A crystal grown by magma and a crystal grown by bacteria can end up looking almost identical under a microscope. This is not a Mars problem. It is one of the oldest arguments in the history of geology, and it is the entire reason NASA will not say the word life about a rock that, chemically, looks like exactly what life would leave behind. Not caution, not fear. A specific, structural fact about how the universe erases its own paper trail. I want to show you what that actually looks like, because I watched it happen with my own hands before I ever heard the word Mars. When I was 7 years old, I worked the counter in my father's print shop on Pitkin Avenue in Brownsville, Brooklyn. And in the back room, next to the trays of type and the smell of solvent, there was a jar somebody had given him as a gag gift called a chemical garden. You dropped crystals of iron sulfate and copper sulfate and cobalt chloride into a jar of what chemists call water glass, sodium silicate dissolved in water. And over about a day, without anyone touching it, without any life in it whatsoever, the jar grew what looked exactly like a tiny underwater forest. Branches, stalks, little bulbous heads like coral. A customer once looked at that jar sitting on the counter and asked my father what kind of plant it was. My father, who ran a print shop and had no formal training in chemistry, told him the truth. It's not a plant, it's rust reacting with glass, and it only looks alive because growing toward least resistance is one of the cheapest tricks matter has. I didn't understand the mechanism until years later, in a biochemistry lab, but I understood the lesson from that jar before I understood almost anything else. A shape that looks purposeful, branching, organized, directional. The exact vocabulary we use for living things can be entirely the output of ordinary chemistry finding a path through a gel. Nobody built that garden. Nobody needed to. And that, structurally, is precisely the argument being had right now about a Martian mudstone called Cheyava Falls. NASA picked Jezero Crater for Perseverance to land in for exactly one reason. Satellite images showed what looked, unmistakably, like a dried river delta pouring into a dried lake bed, the single best-preserved example of that kind of geology anywhere on the planet. If Mars ever had a good shot at supporting life, geologists reasoned, it would be here, in standing water that lasted long enough and calm enough for fine sediment and organic material to settle and stay put instead of getting scoured away. That's not speculation dressed up as science. It's the same logic a forensic investigator uses picking which room to search first. And it's exactly why, when Perseverance found something strange in a formation called Bright Angel on the western edge of that same crater, nobody was shocked that it was here. They'd built a multi-billion-dollar mission on the bet that here was where the evidence, if any existed, would have had its best chance to survive. Cheyava Falls is a rock about the size of a coffee table, arrowhead-shaped, sitting in a dry river channel called Neretva Vallis, a valley a quarter-mile wide that once carried water into Jezero Crater during Mars's oldest geological period. A period whose rock record, at the crater rim, has been dated to more than 3.9 billion years old, which means that valley stopped flowing so long ago that 85% of the entire history of the solar system has happened since, before anyone on Earth had invented the wheel, or writing, or, for that matter, oxygen-breathing animals. Inside Cheyava Falls, Perseverance's cameras found two features that made the science team stop everything. The first were tiny nodules, 1/10 to 2/10 of a millimeter across, about the width of a couple of human hairs laid side by side, made of a mineral called vivianite, an iron phosphate. The second were millimeter-sized off-white splotches ringed in black, nicknamed leopard spots, containing that same vivianite alongside a second mineral, greigite, an iron sulfide. Here is the mechanism, because I don't believe in handing you a discovery without the chemistry underneath it. Vivianite and greigite are both what chemists call reduced minerals. They form when electrons get stripped off organic carbon and handed to iron and sulfur instead. On Earth, that exact electron handoff is one of the oldest tricks life uses to make a living. Certain bacteria, sitting in oxygen-starved mud, eat organic matter and breathe iron or sulfate instead of oxygen. And vivianite and greigite are, quite literally, their metabolic exhaust. Find those two minerals sitting inside organic-rich mudstone, arranged in a pattern that suggests a reaction front moving through the rock, and you have exactly the forensic picture a biochemist would want if bacteria had once been living and feeding and dying inside that mud. That's not a guess. That's the same chemistry, the same electron bookkeeping, happening in a marsh outside Boston this afternoon, with nobody needing to invoke another planet to explain it. So why hasn't NASA just said the word? Because the very same scientists who found this pattern immediately went looking for a way to prove themselves wrong, which is the single most important habit in the entire discipline of science, and one I wish more people understood as a virtue instead of a weakness. They noticed something else in that rock. Millimeter-sized crystals of olivine, a mineral that only forms from cooling magma, sitting inside the same veins as the calcium sulfate that framed the leopard spots. That olivine raised an ugly possibility. What if the water that built those spots wasn't the cool, muddy, life-friendly water of a lake bed at all, but violent hydrothermal fluid, moving through cracks long after the mud had already turned to stone? That question matters because hot, mineral-rich fluid can drive the exact same redox chemistry, the exact same iron-sulfur electron handoff, with no organisms involved at all, the same way a black smoker chimney on the floor of Earth's oceans builds towers of metal sulfide through pure inorganic plumbing, no bacteria required, at temperatures hot enough to sterilize anything alive instantly. I'll grant you the complication that cuts against my own argument, because a good scientist always should. Those same black smoker vents, just a short distance away from the scalding plumbing itself, in the narrow band where the temperature drops enough to allow it, are absolutely crawling with life. Tube worms, blind shrimp, entire ecosystems that never see sunlight, which is exactly why hydrothermal vents are one of the leading theories for where life on Earth got started in the first place. So the presence of hot fluid doesn't rule biology out either. It just means the argument has to be more careful than hot equals dead, because on this planet, at least, hot and dead are not the same claim. If Cheyava Falls got its spots from a violent pulse of scalding fluid moving through already dead rock, the chemistry is real and the biology is nothing. The team checked. They looked at the surrounding rock for the telltale mineral transformations that only happen at those extreme temperatures, and, as of the most recent published analysis, they didn't find them, which doesn't prove biology. It only removes one specific way for a skeptic to explain the pattern away. That is what a potential biosignature actually is. Not a maybe, but a scoreboard, with entries being crossed off one at a time. Astrobiologists actually built that scoreboard into a formal tool. It's called the cold scale. Confidence of life detection. 7 rungs. From the bottom, which is simply detecting a chemical or a shape that resembles something biology can produce, up to the top, which requires multiple independent lines of evidence from multiple independent samples that cannot be explained by any known non-biological process, confirmed by laboratories that never compared notes. Before publishing, Cheyava Falls sits low on that ladder. It has cleared some of the lower rungs, nowhere near the top. It has organic carbon, it has the right minerals, it has a plausible reaction front geometry. What it doesn't have, and can't have, until the rock is physically back on Earth, is confirmation from an instrument sensitive enough to check the one signature that matters more than any mineral, the isotopic fingerprint that life, and only life, reliably leaves in the carbon it touches. Here's the fingerprint. Life on Earth runs almost entirely on an enzyme family that does something curious. When it grabs carbon dioxide out of its environment to build sugars and eventually everything else a cell is made of, it very slightly prefers the lighter carbon atom, carbon-12, over its heavier cousin, carbon-13. The preference is small, a matter of a few parts per thousand, but it's consistent, mechanical, and traceable, because pulling a lighter atom through a chemical reaction is easier than pulling a heavier one, the way it's easier to sprint carrying a paperback than an encyclopedia. Every living thing on this planet, without exception, leaves organic carbon measurably lighter than the inorganic carbon sitting right next to it. I did not learn this from a textbook. I learned it from a professor named Halloran, who nearly failed me for missing why it mattered. Professor Halloran ran a biochemistry seminar I took as a graduate student, and on my first isotope problem set, I got every number right and every conclusion wrong. I'd shown, correctly, that a sample of ancient carbon was isotopically light, enriched in carbon-12, and I'd written, confidently, that this proved biological origin. Halloran handed the set back with one sentence in red ink. Proved, or merely failed to rule out? I remember being furious about it, the way you're furious at 24 when someone is right and you are not. He kept us after class and drew 2 columns on the chalkboard. In one column, every known way life makes carbon isotopically light. In the other, which he made me help fill in over the following weeks, every known non-biological, purely geochemical way of producing the exact same signature. Certain reactions involving hot water and iron, certain kinds of graphite formed under pressure and heat with no organism anywhere near it, chemistry that counterfeits the fingerprint without ever housing a cell. The second column, when I started it, had 2 entries. Today it has considerably more, because geochemists have spent the decades since finding new ways to fake the one signature we once thought only biology could produce. Halloran's lesson wasn't that isotopes are useless. It was that no single number, however elegant, however consistent with life, is ever allowed to stand alone as proof. It has to survive every attempt anyone can mount to explain it away without biology. That lesson, more than anything else I learned in a laboratory, is the exact discipline NASA's applying to a Martian mudstone decades later, rung by rung, on a scale Halloran would have recognized immediately, because he basically built one of his own on that chalkboard, 1 column at a time. So why hasn't Perseverance simply pointed an instrument at Cheyava Falls, read off the carbon isotope ratio, and settled the entire argument on the spot? Because the instrument precise enough to measure that fingerprint reliably, sensitive to differences of a few parts per thousand, working with sample chambers smaller than a grain of salt, exists in exactly one kind of place. A laboratory on Earth, the kind with humidity control, vibration isolation, and technicians who spend entire careers calibrating a single machine, which is the actual, unglamorous, structural reason that little tube of drilled mud named Sapphire Canyon is sitting in a titanium tube on the floor of Jezero Crater right now, cached, waiting, while 2 space agencies argue over the billions of dollars it would cost to go retrieve it. The case isn't closed because the one piece of equipment that could close it doesn't have wheels. I've spent as much of my life writing about explorers, finding things that turn out not to be alive, as I've spent measuring things that might be. Long before I had a science column, I wrote pulp fiction for a magazine called Nova Quarterly, edited by a man named Walt Bregman, who had two settings, delighted and apoplectic. I want to tell you about the story cycle that nearly got me fired, because it is, in miniature, the exact argument I've been making about a Martian mudstone for the last several minutes, except I wrote it 20 years before Cheyava Falls existed, without knowing I was rehearsing for it. I called the cycle the Null Cases. Each story followed a different team of explorers finding something on some world. A shape in a rock face, a rhythm in a radio signal, a structure buried in ice, that looked unmistakably built, or grown, or alive. And each story was, on purpose, about the slow, unglamorous, multi-month process of ruling it out. In one, it was wind erosion. In another, a mineral vein. In another, a perfectly natural orbital resonance that only looked like a signal because the instrument was tuned wrong. Bregman hated it. He'd call me into his office waving the manuscript and say some version of the same thing every time. Readers want the alien, Katz, not the geology winning. I told him the geology winning was the whole point. That the actual heroism in exploration is the discipline to let the boring explanation win when it's true, instead of the exciting one. He ran the stories anyway, grumbling, and they sold worse than almost anything else I wrote that decade, and I understood exactly why. An ending where nothing is found is deeply unsatisfying to a reader's nervous system, even when it's the responsible ending, even when it's the true one. I bring this up because I think that exact appetite for the alien over the geology, for the satisfying verdict over the honest scoreboard, is precisely what's driving the belief I opened this video attacking. People don't want a scoreboard. They want a verdict. And a rock on Mars, unfortunately for all of our nervous systems, does not care what we want. Bregman's readers got their verdict eventually, just not from fiction. In December of 1984, a search team on snowmobiles in the Allen Hills region of Antarctica nearly rode past a green-gray rock a little smaller than a brick. It was catalogued, boringly, as meteorite number 84001, filed away, and mostly forgotten for close to a decade. In 1993, researchers realized it hadn't come from an asteroid at all. It had come from Mars, blasted off the planet by an impact around 16 million years ago, and drifting through space until it fell to Earth roughly 13,000 years ago. Then, in August of 1996, a NASA and Stanford research team announced, at a press conference carried live around the world, that carbonate globules inside that rock, globules that had themselves crystallized on Mars around 3.9 billion years ago, very nearly the same age as the mud sitting inside Cheyava Falls today, contained microscopic, worm-shaped structures, chains of a mineral called magnetite and organic compounds, all of which, taken together, they argued, looked like fossilized Martian bacteria. The sitting president of the United States held a briefing about it. A famous astronomer said, on camera, that if it held up, it would rank among the great discoveries in the history of science. It didn't hold up, or at least not the way anyone hoped. Over the following years, researchers found that laboratory shock waves, the same kind of violent compression that blasted the rock off Mars in the first place, can produce magnetite crystals with nearly the same shape scientists had pointed to as uniquely biological. The organic compounds turned out to be difficult to fully separate from contamination picked up during 13,000 years sitting in Antarctic ice. The worm-shaped structures were, on closer measurement, smaller than almost any known free-living cell has ever been found to be, small enough that most biochemists doubt they could hold the minimum machinery a cell needs to run itself. One by one, nearly every column on that scoreboard got a plausible non-biological explanation entered next to it, the same way Halloran's chalkboard filled in over the years. Today, most planetary scientists consider the biological explanation for AL 84001 the least likely one on the table. Not because anyone proved life didn't do it, but because equifinality did what equifinality always does. It found enough ordinary chemistry to make the extraordinary explanation unnecessary. That took most of 30 years. Cheyava Falls is 1 year into that same process, and it has, so far, survived longer than AL 84001 did. I need to tell you something uncomfortable here, because I think a person explaining all of this to you without admitting his own history with it would be lying by omission. In September of 1996, 1 month after that press conference, I wrote the science column I'd been syndicating for years. I called it Plain Sight, on the theory that most of science is hiding in things people walk past every day. And I wrote it about AL 84001, and I got it wrong. Not factually wrong. I reported the findings accurately. Wrong in tone, wrong in confidence, wrong in the thing that actually matters most in science writing, which is calibrating how sure you sound to how sure the evidence actually is. I wrote that this might be the discovery that ends the question of whether we're alone in the universe. I used the word proof in a sentence where I should have used the word candidate. I had, by then, spent years building the exact discipline I'd learned from Halloran's chalkboard, and I still let the good story get ahead of the careful one, because the good story is simply more fun to write, and for one column, I wanted to be the person announcing the miracle instead of the person auditing it. I bring up my own mistake, not to punish myself publicly, which is a cheap trick performers use to look humble, but because it's connected to something that genuinely still unsettles me, and I'd rather be honest with you about it than tidy it up. Halloran's isotope test, the one I've been holding up for the last several minutes as the gold standard, the fingerprint only life reliably leaves, is not settled science either. Not even here. Not even on Earth. Not even after decades of people trying to close the case. There are rocks in southwestern Greenland, in a formation called the Ishua supracrustal belt, close to 3.7 billion years old, that carry that same isotopically light carbon signature. Carbon-12 enriched exactly the way biology enriches it. And researchers have argued about whether that carbon is the oldest direct evidence of life on Earth since at least 1996, the same year as the AL 84001 announcement. In 2016, a separate team reported finding what looked like fossilized stromatolites, mats built by ancient microbial colonies, in exposed Ishua rock that had just recently emerged from retreating snow. Other geochemists came back within a few years and argued that some of that same light carbon can form through purely metasomatic reactions, hot fluids reorganizing carbon at depth with no organism required. The identical structural argument the Cheyava Falls team is currently having about hydrothermal fluid and olivine, just older, angrier, and fought over Earth rock instead of Mars rock. Here is what unsettles me. If we cannot fully close this argument about our own planet, where we can walk up to the outcrop, chip off as many samples as we want, and run every instrument ever built, then I no longer know, with total honesty, whether bringing Sapphire Canyon back from Mars will actually end the argument either, or whether it will simply move the same argument into a nicer building. So let's go back to the belief I opened with, because I think you can now see exactly why it's wrong, and exactly what would have to be true for it to become right. The belief was that a pattern resembling life is basically evidence of life, and that NASA's caution is just institutional hedging. What we've actually walked through is that resemblance is never enough, on Mars or in Greenland or anywhere else, because chemistry is extraordinarily good at counterfeiting the specific signatures biology leaves behind, not as some rare edge case, but reliably, repeatedly, as a structural feature of how atoms rearrange themselves whenever electrons move from one element to another looking for a lower energy home. What would actually change the picture isn't a better rock or a sharper photograph. It's a shift from asking, does this pattern look like life, to asking, can I reconstruct, step by step, the actual physical history that built this pattern? And does every non-biological version of that history fail somewhere specific? That's a harder question. It's also the only question equifinality has ever respected, on this planet or, if we ever get the chance to ask it properly, on that one. I've had almost this exact argument for nearly 40 years with a radio astronomer named Ruth, who I met at a conference in the 1980s and who has spent most of her career listening to the sky for something that isn't background noise. Ruth and I disagree about almost nothing scientifically and almost everything temperamentally. Every few years, some telescope somewhere picks up a signal that briefly looks structured, a repeating pulse, a narrow, unnatural-seeming frequency. And for about 48 hours, the world gets extremely excited, and then, almost every time, it turns out to be a pulsar nobody had cataloged yet, or a satellite, or once, memorably, a microwave oven at the observatory itself being opened mid-cycle by a hungry graduate student. Ruth has told me, more than once, after another one of these false alarms, that what actually keeps her up at night isn't the fear that we're alone. It's the fear that we might not be, and might never be able to tell, because the exact same problem sitting inside a Martian mudstone is sitting inside every radio signal she's ever analyzed. A pattern that resembles intention is not the same thing as intention, and the universe is extremely good at producing patterns that resemble intention entirely by accident, at every scale, from a jar of rusting crystals in a Brooklyn print shop, to a rock on Mars, to a blip in a radio telescope pointed at a star 400 light-years away. Here is the larger question hiding inside the small one, and I think it's the actual reason this story has held your attention this long. We assume detecting life is a chemistry problem. Find the right molecule, the right isotope, the right mineral, and the question resolves. But every example I've given you tonight, the chemical garden, Halloran's chalkboard, AL 84001, Isua, Cheyava Falls, Ruth's 48-hour false alarms, points at something else entirely. Detecting life, or mind, or intention, anywhere, including in each other, has never actually been a chemistry problem or a signal processing problem. It has always been a history problem. The only thing that has ever separated a living pattern from a dead one is the specific causal path that built it. And causal paths, once finished, do not leave a label behind. They leave only the shape, and the shape is neutral. It will testify for whichever side asks it the right question. Human beings evolved, for extremely good reasons, to be almost pathologically eager to see intention behind a shape. A face in a rock formation, a message in a coincidence, a mind behind a spotted pattern on a rock 100 million miles away. Because for most of our evolutionary history, mistaking a shadow for a predator cost you nothing, and mistaking a predator for a shadow cost you everything. We are, every one of us, running the exact same threat detection machinery that makes a lonely radio astronomer's heart jump at a pulsar, pointed now at a smear of iron and sulfur inside a Martian rock, and the machinery does not care that it's 3.9 billion years too late to matter to anyone's survival. It fires anyway. Sapphire Canyon is still sitting in a titanium tube on the floor of Jezero Crater tonight, cached, waiting. It has been waiting since July of 2024. In January of 2026, the United States Congress passed a spending bill that, in effect, ended the Mars sample return program as it had existed, the mission that was supposed to go get tubes like this one and carry them home, while leaving a placeholder line item for some future, cheaper, not yet designed version of the same idea. Meanwhile, a Chinese mission called Tianwen-3 is aiming to launch by 2028 and return its own Martian samples from a single site by 2031, which means it's entirely possible that the first Mars rock ever cracked open in a lab on Earth won't be the one with the leopard spots at all, decided not by geology, but by which country's legislature moves faster. I want to be honest with you about what Sapphire Canyon will and will not do whenever it finally does get here, on whichever mission ends up carrying it. It will not, on its own, answer the question that made you click on this video. No rock ever has. Not the one in Antarctica in 1996, not the one in Greenland that's still being argued about today, not this one. What a return sample can do, the only thing any sample has ever been able to do, is let us ask the harder question properly. Reconstruct the history instead of admiring the shape. And even then, Halloran's chalkboard tells me the second column never stays empty for long. So if you remember one thing from the last 20-some minutes, let it not be the word Mars, or the word biosignature, or even the number 3.9 billion, though you'll probably remember that one anyway because I built this whole video to make sure you would. Let it be this, the belief that started this video, that a pattern resembling life is basically evidence of life, and that the only thing between us and an answer is some agency's nerve, was never really a belief about Mars. It was a belief about how proof works, and it happens to be wrong everywhere it's ever been tested, on every world we've ever had the instruments to check, including this one. NASA didn't build a 7-rung scale because it's cowardly. It built one because a boy's chemical garden, a Greenland rock older than complex life, and a Martian mudstone with a name borrowed from a waterfall in Arizona are all, at the level that actually matters, telling us the exact same true thing, and most of us have simply never been forced